Hi all, welcome to LearnCodeRepeat. So today's problem is list cycle, which is a cycle detection problem, and we'll be solving this using Floyd's cycle detection algorithm. It's also called as Tortoise and the Hare algorithm. So let's first look into the problem. So the problem says, given a linked list, return the node where the cycle begins. If there is no cycle, return null. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that tail's next pointer is connected to. Note that POS is not passed as a parameter. Notice that you should not modify the linked list. And the follow-up is, can you solve it using O of 1 space, which is constant memory. So here the example is 3, 2, 0, minus 4, and then minus 4 connects to 2. So for this example purpose, they have given that their position is 1. So that is the first index. So minus 4 connects to 1 here. So let's take an example and see how Floyd's algorithm will help us. So let's consider this as the linked list. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 8 again points back to 3. So what Floyd's algorithm says is it uses 2 pointers, and it says that one pointer moves slowly and the other pointer moves 2 times as fast as the slow pointer. And when we go over this linked list, there will be a point where both the pointers will meet inside the loop, since it's in the loop, right? So if I normally go over this list, right, I will go to 1, 2, 3, 4, 5, 6, 7, 8. Then again I will come back to 3, and this will go in a loop, right? Infinite loop. So what Floyd's algorithm says is, if you use 2 pointer, one that moves slowly and one that moves twice of the speed of the slow pointer, then inside this loop there will be some point where both the pointers will meet. If both the pointers meet, then we can say there is a cycle. So here it is not saying that that is the first point where it meets. The question is about giving back the first point where it meets, right? So in the question they have asked, given a linked list, return the node where the cycle begins. So we have to return that particular node where the cycle begins, right? So if both the pointer meets inside the loop, that may not be the node where the cycle begins. That may just indicate that there is a cycle inside the linked list. So how to check where the cycle begins? For that, the algorithm says that keep the fast pointer as is, where both the pointers met at the same position, and have the slow pointer reset back to head, and then move both slow and fast pointer at the same speed, one node at a time. And after that, when both the pointers meet at that time, that node will be the node where the cycle begins. Okay, so let's see this with an example, right? So let's say our slow pointer is marked as S and fast pointer is marked as F. Okay, so initially both will be at the same position, which is at head, right? Now when the slow pointer moves one position to this point, fast pointer will move 2 positions to this point, right? Again, slow pointer will move 1 position, but at the same time fast pointer would have moved 2 position, right? So fast pointer will first move 2 position, this here, and slow pointer will be here. Okay, then again fast pointer will move 2 positions, so it will be 1, 2, it will come to this point, and slow will come to this point. Again fast pointer will move 2 positions, 1, 2, so it will be here. Slow will move 1 position, it will be here. Okay, again fast pointer will move 2 position, it will be here, but at the same time slow pointer will move this position, 1 position, so it will come here, right? So it won't move at the end of the loop, it will still be a different position than fast pointer, right? Now again fast pointer will move 2 position, and fast pointer will now come here, and slow pointer will also move 1 position, and slow pointer will also come here, right? Now both fast and slow pointer is at 7, so this means that cycle is there. Okay, so now we have identified the cycle. Now let's keep the fast pointer at this position and reset this slow pointer back to our head position, and now move both the pointers one unit at a time, that is one node at a time. So first slow pointer moves to this position, at the same time fast pointer will move to this position, then again slow pointer will move to this position, and fast pointer will also move to this position. Now both the pointers have met, so this is the starting point, and that's what we are expecting. 3 is the starting point of the loop, of the cycle, right? Now why does this algorithm works, right? So consider that if this is a distance m, and where it met, right, where both the pointers met initially, this is, let's say, x, right, and this whole loop distance that is there is the y distance, right? So m plus x is actually a multiplier of y. Okay, so m plus x equal to some z into y, and by using this proof we can say that once the cycle is detected, we can move one step at a time, and there will be a point where both the pointers slow and fast will meet, and that will be the starting point. I won't go in much detail into the proof, but you can look into the Wikipedia article, and there are multiple other articles on Floyd's algorithm that explain in detail why this algorithm works. But on a general note, since slow is moving one step and fast is moving two step, if you go in a cycle, there will be some point where both of them will meet. So that is understood, right? Since it's going in the cycle, at some point both of them will meet. So cycle detection is easier. And once that is met, we just need to reset the slow pointer and move both slow and fast at the same time, one node at a time. And when they meet again, that is a point where the actual loop started. And this algorithm is also important because that way we will also come to know if we have to remove the loop, right, remove the infinite loop or remove the cycle, at what point we need to remove the reference, right? So here, in case if we have to remove the cycle, right, once we know that both the fast and slow points meet here, this is the beginning of the loop, right, we can again make the fast loop go back into the loop until the fast dot next equal to slow, and when it is equal to slow we can remove this particular reference. So that way we can remove the loop. So if the question was also to remove the loop, we could have done that in the next step. Okay, so let's look into the algorithm for this. So first we'll check if the head is null. If it is null, then we can directly return null as the value. So here I'm checking if head is null or head dot next is null. In that case I can directly return null. Now I'll have a slow and fast pointer. So both slow and fast pointer is first pointing to the head. Now in a loop I will try to traverse the list node. For slow it will be one node at a time. For fast it will be two node at a time. So I've used a do while loop here. So do slow equal to slow dot next and fast equal to fast dot next. And after that again, if my fast is not equal to null, because I need to take care that it can be a non-cyclic linked list, right? In that case my fast can be null, right? So if my fast is not equal to null, then fast equal to fast dot next. So I'm doing two operations here for the fast, right? Fast is going over two nodes here. Now here, if fast equal to null, right, in that case we can directly return null, right, because we know that it is null because there is no cycle, so we can directly return null here. Also here we can check if fast equal to null. In that case also we can return null. So in these both cases we are returning null if there is no cycle. And this loop will exit if slow is equal to fast. So this is a cycle detection, right? So after exiting this loop, we know that the cycle has been detected. Now to check which node started the cycle, for that we need to reset the slow back to the head. So here what I did is I reset the slow back to head, and I am doing a simple while loop till slow is not equal to fast. Both slow and fast is moving at the same speed, that is one node at a time, and this while loop will exit when slow equal to fast. At that time I can directly return the slow node. So let's run this code. The test case runs fine. Let's submit this. And the code is accepted. So the runtime for this will be O of n, where n is the total number of list node that we can have. So in worst case it will be O of n. And since we are not using any additional space, so the space complexity is O of 1. So I hope you like this video. Please do hit the like button and do subscribe to the channel for future such videos. Thank you.